Hello and welcome to Math with Mrs. Becker. Today we are looking at College Algebra, Chapter 1, Section 4. We focus on what are called transformations. At the top of the notes, I just gave you a chart that you can use as a reference. It shows you those basic parent functions. I also included things like if the parent is an even or an odd function, what the domain and range would be. So for example, this is the linear parent function. It's the most basic linear function. It is just a single x. This is its shape. It is an odd function because it does touch the origin. You can rotate it 180 degrees and it would line up perfectly. Again, I also included domain and range. Going left to right, this would include all x values. Going down to up, it would include all y values. So you can see linear, quadratic, cubic, absolute value, radical, and cube root functions. So this is just as a reference for you. Throughout the section, you're going to see that sometimes when you have really complex graphs that you look at in higher math, what happens is they take those parent functions and they shift them up, down, left, or right, or they stretch them, or they compress them, or maybe they reflect them. And that's how you get those more complex graphs. When you do shifts, stretches, shrinks, and reflections, those are called transformations, and that's what we're going to focus on today. The first type of transformation we are going to look at is a shift. In the function, that's when you add or subtract. Now, back in Algebra 2, we called these translations or slides. Same thing. This book calls it a shift. So if you are more comfortable calling it a horizontal translation or a vertical slide, no problem. It means the same thing, okay? If you have a function, if you want to do a vertical shift, vertical, that means that you're changing the y's because you are changing the location of the graph up or down the y-axis. In the equation, what happens is they take the original function, rewrite it the way it is. If you want to slide your figure up, you add to the end. If you want to slide your figure down, you subtract to the end, okay? Horizontal. Horizontal, you will be changing the x because it's the x-axis that runs side to side in that horizontal direction. The formula for horizontal, even back, think about Algebra 2 when we did this. It was x minus c. C is the direction and the number of units that you're moving. If you're moving to the right, you're putting a positive number in here, so notice it remains a negative. If you're moving to the left, like let's say I want to move to the left 2, well, the left is the negative direction. If I put a negative 2 in there, minus a negative, that becomes a plus. So that's why it's a plus for left and a minus for right. It's because the formula contains a negative. So let's go ahead and do some transformations. What they will do for college algebra is they will give you a parent function. It is up to you to be able to create an XY table so you can graph the parent function and see what the shape is. X squared, now that is the basic quadratic. Quadratics, you can go to the left, you can stay at 0, you can go to the right. So what we want to do is include -2 to +2. So x is -2, -1, 0, 1, 2. In order to get the y value, you have to fill the x into the original function. -2 squared is +4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. So these are the ordered pairs that represent the parent function. Now I'm going to go ahead and graph it so I can look at the shape. Left 2, up 1, 2, 3, 4. Left 1, up 1, 0, 0. Right 1, up 1. Right 2, up 4. This is a quadratic. We are familiar with parabolas, so we know it's a U-shaped graph. That is our parent function. That is f of x. Now what they're going to do is go ahead and give us new functions. Each function is a transformation of the parent. So we have to figure out what is the transformation that occurred, change the ordered pairs to represent the new function, and then graph it on the same grid. So here my parent is x squared. I notice that x squared stayed the same. They minus to the end. If you minus to the end, that is a vertical shift or slide or translation. Here, if I look at my little cheat sheet, if you minus to the end, you're moving downwards. So we are going down 1. If you are changing in a vertical direction, you change the y in the ordered pair. The x stays. The y, if I want to make it go down 1, I need to minus 1. So I need to take the ordered pairs from the parent function. Keep every x the same. -2, -1, 0, 1, 2. Take every y and minus 1. 4 minus 1 is 3. 1 minus 1 is 0. 0 minus 1 is -1. 1 minus 1 is 0. 4 minus 1 is 3. Now you graph this on the same grid and you label this g of x. So to the left 2 up 1, 2, 3. To the left 1, stay at 0. 0, go down 1. To the right 1, stay at 0. To the right 2, go up 1, 2, 3, connect them. This function is g of x. Now the next one. Every single time you have to realize that we go back to the original parent function. H of x is a transformation of the parent function x squared. Notice I'm adding or subtracting. Anytime you add or subtract, it is a shift. This is in parentheses. If it's in parentheses, it's horizontal. So I have a horizontal shift. Now we need to figure out which direction. This remained a minus. That means that I put a positive 1 in here, so I am going to the right 1. The way that you change the order pairs. If it's a horizontal change, you change the x. If I want to go to the right 1, I have to add 1 because the right is the positive direction. I'm not changing the y. So I need to add 1 to all of the x's from the original parent function. -2 plus 1 is -1. -1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. And I'm going to go ahead and add a little paper under here so I can keep going. And there we go. So I'm adding 1, so I have 2 plus 1 is 3. Now my y's, I need to keep them the same. So it's 4, 1, 0, 1, 4. Graph it on the same grid, and we're going to call it h of x. So I go to the left 1, up 1, 2, 3, 4. Stay at 0, go up 1. Go to the right 1, stay at 0. Go to the right 2, up 1. Go to the right 1, 2, 3, up 1, 2, 3, 4. Connect them. This graph right here, this represents the function h of x. Last one for transform or translation shift slides. Okay, this time we have both. We have a horizontal and we have a vertical. I'm adding in two different spots. Adding and subtracting represent shifts. In parentheses, it's horizontal. So I have a horizontal shift. It's a minus, or sorry, it's a plus. In order for this to become a plus, I had to put a negative number next to that subtraction sign. So it's minus and negative. Because this is a plus, I'm going to the left 2 units. Now adding at the end, not in parentheses, that represents a vertical shift. Vertical, if you're adding to the end like we are going up 1. So we are taking this graph and we are going to the left 2 and up 1 to change the order pairs. Horizontal, you change the x. To go to the left, that's the negative direction, so I minus 2. Vertical, you change the y. To go up 1, you have to add 1. So again, I'm going to take the original ordered pairs because this is a transformation of the parent. I need to take every x minus 2. -2 minus 2 more is -4. -1 minus 2 is -3. 0 minus 2 is -2. 1 minus 2 is -1. 2 minus 2 is 0. Then I need to take all the y's and add 1. 4 plus 1 is 5. 1 plus 1 is 2. 0 plus 1 is 1. 1 plus 1 is 2. 4 plus 1 is 5. Graph those on the same grid. This represents k of x. So -4, 1, 2, 3, 4, up. 1, 2, 3, 4, 5. There's the first point. Go to the left, 1, 2, 3, up, 1, 2. So 1, 2, 3, up, 2. Awesome. Left 2, up 1. Left 1, up 2. Stay at 0, up 5. So here is my graph. Go ahead and connect them. This is k of x. Okay, before we move to the next side, we are going to be focused on the parent function, the absolute value of x. What they're going to do is give us a graph, and we have to figure out what the equation would look like. We so far have studied shifts. So what we need to do is figure out if this thing moved up, down, left, right, or a combination. The easiest way to do that is to compare where that point is. In the parent function, the point is located at 0, 0. So keep that in mind as we turn the page. So again, these three graphs, they are transformations from the parent function, the absolute value of x. When you have the absolute value of x, the point is right at the origin. So notice this graph is up 1, 2, 3. So this is up 3. If you are going up 3, that is a vertical translation or a vertical shift. They want us to find what the equation would be. Well, if you're doing a vertical shift, you rewrite the function the way that it is. So it's the absolute value of x. If I want to go up 3, I just add 3 to the end. Done. Now this graph, the point should be at the origin. If it's the parent, it is to the left 2. If you're going left or right, that is a horizontal shift. So it's x minus whatever direction you're going. We went to the left 2, so that's a negative 2. If you minus a negative, it changes to a plus. So x plus 2 within the absolute value bars would represent this graph. The next one, from the origin, they went right 2 and down 1. So it's a combination of horizontal and vertical. When you're going to the right, it's within the bars. It's x minus, we went to the right 2, that's a positive value. To go down 1, you minus 1 to the end. So that, my friends, concludes our shifts, slides, translations. Now we're going to go ahead and talk about reflections. If you have a reflection can be thought of as a mirror image over either the x or the y axis. The way that you know you have a reflection is that you have a negative added into your original function. If that negative is out front, if it's in front of everything, you're flipping the figure upside down. So you are reflecting over the x. If you reflect over the x, you keep the x the same, you have to change the y's. And the way that you're changing the y's is you're changing the sign. Positives become negatives, negatives become positives. If your x is the only thing that has the negative, so it's not out front, maybe it's just with the x in parentheses, maybe it's inside absolute value bars or underneath a radical. If it's only with the x, you're reflecting across the y. If you reflect across the y has to stay the same. What you're doing is changing the sign of all of the x's. So let's go ahead and look at another round of graphs. If our parent function is the square root of x, this time I cannot go negative 2 to 2 because I cannot put a negative underneath the radical. That would make it imaginary. So when it's the square root function, our x's are 0, 1, and 4. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. Those are the values that can represent the parent function, the absolute or the square root of x. Graph that. 0, 0, 1, 1, go to right 1, 2, 3, 4, up 2. There is the parent function. That is our f of x. Now, they're doing the same thing. They are going to give us a transformation function. We have to identify the transformation, change the ordered pairs, graph it on the same grid. If there's a negative out front, that means that you are going to reflect over the x. If you reflect over the x stays the same. You have to change the y's. So when I take these ordered pairs, the x's stay 0, 1, and 4. The y's have to change their sign. Well, there's no such thing as a negative 0, so that stays 0. 1 becomes negative 1, 2 becomes negative 2. So I have 0, 0, go to the right 1, down 1, go to the right 4, down 2. So what happened is it took this shape and it just flipped it over the x. Next one, notice I have two different things going on here. There is a negative up front, again, negative just like we just did, that reflects it over the x. Then I'm adding or subtracting. Anytime you add or subtract, that is a shift. This time it is only to the x because notice it stayed underneath the symbol. If it was vertical, it would have to be after the symbol. This is underneath, so it's horizontal. So I have a horizontal shift. Horizontal, remember it's x minus, so in order for this to be a plus, I am going to the left 2 because I had to have put a negative 2 underneath that symbol in order to make it a plus. To change the ordered pair, if you are reflecting over the x, you need to change all of the signs of the y's. You keep the signs of the x's the same. Horizontal, you're changing the x. If it's a shift, you're adding or subtracting. If I'm going to the left, that's the negative direction, so I'm minus 2. I need to go back to the original order pairs, take every x minus 2. 0 minus 2 is negative 2. 1 minus 2 is negative 1. 4 minus 2 is 2. I need to take every y and change the sign. There's no such thing as a negative 0, so it's 0. 1 becomes negative 1, 2 becomes negative 2. Graph it, and we need to label it h of x. So I go to the left 2, stay at 0. Left 1 is down 1. Right 2 is down 2. That is my h of x. Last one, and then we're going to go ahead and go to our last type of transformation. This time again, I have a negative. It is underneath the symbol. That indicates that it only goes to the x. So this time, we are going to reflect over the y-axis. I'm adding. Anytime you're adding or subtracting, it is a shift. This is at the end of the problem, so it's a vertical. We have a vertical shift. It's adding, so we're going up 3 to change the order pairs. If you reflect over y, you keep the signs of y, you have to change the signs of x. Vertical shift. Vertical, you change the y. Shift, you add or subtract. I'm going up 3. So it's y plus 3. Go back to your parent function, these original order pairs. Take every x, make it the opposite. The opposite of a 0 is still a 0. Opposite of 1 is negative 1. Opposite of 4 is negative 4. Take every y and add 3. 0 plus 3 is 3. 1 plus 3 is 4. 2 plus 3 is 5. Graph it, that is m of x. So stay at 0, go up 1, 2, 3. There's my point. Negative 1 up 4. Negative 1, 2, 3, 4 up 5. Go ahead and graph it. That is m of x. And that concludes our little section on reflections. As you are working with transformations, there's actually 2 different categories. When you are doing shifts, moving things up, down, left, or right, or reflections, flipping them over the x or y axis, those types of transformation are called rigid transformations. And the reason why they're called that is because the shape and the size of the original function does not change. The only thing that changes is the position of that object within the coordinate plane. It looks the same, it's just maybe flipped upside down and in a different spot. It is the same shape, it is the same size. However, there are things that are called non-rigid transformations. And when you have non-rigid transformations, they actually can distort the original object. What happens is you take them and you stretch them or shrink them. In Algebra 2, we called them stretches and compressions. This particular textbook calls them stretches and shrinks. So if you are more comfortable and it makes more sense to say compression, go for it. It's the same thing. Okay, but again, what you're doing is you're taking the ends of these graphs and you're stretching them out or you're pushing them forward and you're distorting it. So your ending result, your graph will not be the same shape or same size. That's why it's called non-rigid. When you are doing stretches and shrinks, what you will notice is that you have multiplication within the function. Okay, so that's also how we're going to change the order pair. If you have vertical stretches or shrinks, vertical, you multiply to the y. If you have horizontal stretches or shrinks, you multiply the scale factor to the x's. If it's vertical, the number will be in front of the function. You keep the number how it is. Okay, keep it the same. If the number is larger than 1, it is a stretch. If it is less than 1, it is a shrink or a compression. When you're doing horizontal, you have to do the reciprocal of the number. So whatever number is being multiplied to the x, you flip it upside down. That's the number that you multiply to x. If the reciprocal is bigger than 1, it's a stretch. If the reciprocal is less than 1, it is a compression or a shrink. So let's go ahead and end our notes for the day. Our parent function is the absolute value of x. Absolute values, you can have negatives. So I can go -2, -1, 0, 1, and 2. Absolute value, the definition of that is how far, what is the distance from 0 on a number line. So when I put in a -2, what it's saying is how far is -2 from 0 on the number line? Well, that's 2 units. How far is -1 from 0 on a number line? 1 unit away, it's just to the left, but the distance is positive. Absolute value of 0 is 0, absolute value of 1 is 1, absolute value of 2 is 2. So this is my parent function for the absolute value. Left 2 up 2, left 1 up 1, 0, 0, right 1 up 1, right 2 up 2. The absolute value function has that point at the end. This is our parent function. Now we need to go ahead and identify transformations. When you compare these two, here's the parent function. They multiply to 3 out front. If your value is out front, it is vertical. So this is vertical. To see if it's a stretch or a shrink, you look at the number. Vertical, you keep the number the same. This is a 3. 3 is larger than 1, so this is called a vertical stretch. So what happens is they are grabbing this figure top and bottom, and they are stretching it to make it taller. Well, when they do that, it's going to become more narrow. So let's see how that happens. If this is a vertical stretch, you are changing the y. You multiply stretches and shrinks. So that whatever the factor is, you have to multiply it. So I'm keeping the x's the same, -2, -1, 0, 1, and 2. I have to take each y and multiply it by 3. So starting off, it's a 2. 2 times 3 is 6. 1 times 3 is 3. 3 times 0 is 0. 1 times 3 is 3. 2 times 3 is 6. Graph it and label that h of x. So I go to the left 2. I'm up off the graph just a little bit. Left 1 up 1, 2, 3. 0, 0 stays. Right 1 up 3. Right 2 up 6. Notice it was stretched vertically. That means that it got taller. In turn, it became distorted. It's no longer the same shape because it had to go more narrow. Next one, they are multiplying a number. Multiplying indicates stretches and shrinks. It's out front, so again, it's vertical. If it's vertical, you keep the number the same. 1/3. 1/3 is less than 1, so this is a vertical shrink. So what that means is they're going to take the top and bottom of the original, and they want it to be shorter. Well, in order to make it shorter, it's going to make the shape wider. Vertical, I'm changing the y, so I keep x the same. I take the scale factor, which this time is 1/3, and I multiply it by the y because it's shrinking on the vertical axis, which is the y-axis. Go ahead and find the ordered pair. You're going back to the originals. The x value, -2, -1, 0, 1, and 2. Take all the y's and multiply them by 1/3. 2 times 1/3 is 2/3. 1 times 1/3 is 1/3. 0 times 1/3 is 0. 1 times 1/3 is 1/3. 2 times 1/3 is 2/3. So I go to the left up 2/3. Go to the left 1 up 1/3. Stay at 0 and 0. Right up only 1/3. 2 up only 2/3. So notice this. This is a really wide V. It had to widen out. That's how it shrank vertically. It had to get shorter. Well, in order to do that, it had to become more wide. Last one, guys, and we are done for the day. Notice this time again you're multiplying. If you are multiplying, it means it's a stretch or a shrink. This is inside of the absolute value bars, meaning it only goes to the x. That makes this a horizontal size change. If it's horizontal, you need to do the reciprocal. The reciprocal of 2 is 1/2. 1/2 is less than 1. So this is a horizontal shrink. Horizontal, we have to multiply the factor to x. The reciprocal is what the factor is. So this is a 2. Your factor is the reciprocal of that, so it's 1/2 times x. You keep the y's. Again, going back to the original. 1/2 of -2 is -1. 1/2 of -1 is -1/2. 1/2 of 0 is 0. 1 half of 1 is 1 half. 1 half of 2 is 1. I'm keeping the y's the same because this is a horizontal shrink. It has nothing to do with the y-axis. I go to the left 1, I go up 2. I go to the left 1 half, I go up 1, 0, 0. Right 1 half, up 1. Right 1, up 2. Go ahead and connect the points. This is m of x. Tomorrow you will have a quick quiz on this idea, so please, if you're struggling at all with transformations, take some time to look through the examples in the book as well. I hope you had a great time today. I'll talk to you soon.